we're starting.
Well, welcome to the December 6th, 2022 session of Tangerine SDR and Hamside technical session. My name is Dave, KV0S, and this week I have done a little bit, but probably not as much as others here. So I think I'll just leave it at that. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Number one, the Hamside workshop website, which I did show last week, is now up, and we are now accepting abstracts. So that's the abstract submission is now open. We are still working on the hotel situation, but the abstract submission is open. So that's news number one. News number two, the ARRL is working on this new propagation book called Here to There, and they asked me to write the final chapter of the book. So
Very good.
I wrote that chapter this weekend, a draft, and I got good comments back on it so far. So I think it's going to go forward. And I know Ward Silver liked it, and Carl Lichtenschwab liked it, and Mark Dirks, the ARRL editor, liked it too. So I'm very glad that I got through that. And then there have been all sorts of student research meetings. I have one master's student who's working on a project. He did his thesis proposal today, so that was exciting. And we're getting ready. I'm getting ready to go to the American Geophysical Union meeting next week, and I have to write the annual report for the project very soon as well. So I'm keeping busy. W2NF, back to Nat.
Very good. Next on the list is Bill Engelke, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to you. Good evening to the net. As far as this project goes, we moved into production. The upgrades the students made to the personal space with the station central control system, we did that this afternoon. We did discover one or two remaining bugs that we had not encountered until we put it in production, which isn't that Murphy's Law for you? But anyway, but it's up and running. You may encounter some strange behavior when you try and download things, but that's not being used that heavily yet. Uploading is still seems to be working fine. Dave, I sent you an updated uploader with the configuration, and I'm sure you figured out how to do that because everything is labeled. Although I realized if you're going to use the same configuration file for both a magnetometer and a grate, there's a few changes you have to make to the configuration file, which I only discovered just in the past 15 minutes. So it's a work in progress, but that's pretty normal though. So back to Ned.
Very good. Next on the list is Mike, AAAK. Go ahead, Mike.
Oh, greetings to everyone listening. Back to you, Dave.
Okay. Next in the list is Dan, N4XWE. Go ahead, Dan.
Okay, thanks, Dave, and good evening, everyone. Spent a little bit of time the last week and a half or so trying to figure out the differences between Ubuntu 22.04 and Ubuntu 22.04 Mate. And Mate is the desktop, but I wasn't so interested in that. I was more interested in how they work, how they don't work, and what the nuances are. I'm actually having some issues with compiling software on both of them. It's software that compiles easily on the Raspberry Pi version and doesn't compile at all on the Ubuntu version. So trying to figure out what the problems are and how to fix them. So back to you, Dave.
Well, it's good to know those things. So good luck.
Thank you.
Next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone on the net. All right, thought I was over it, but I've got a little bit of a long tail on the COVID stuff, so life happens. And yeah, got various Antarctic projects I've been working on this week, moving along. And as for this project, I was able to do the modifications to the clock board, biasing the clock driver, and confirmed that the patch seems to be good. Voltage levels are 1.1 volt peak to peak, riding on 1.8 volts. And I think that's a very good bias point. So good to see things moving along on that. And hope to hear what other people have done. Back to Net.
Well, fine business. And next on the list is Hillman Kim. Go ahead, Hillman.
Hello, everyone. Yep. So as Nathaniel mentioned, yeah, the whole team is pretty busy with the preparing for the AGU conference that will be held next week. One thing that I like to note is that last week I attended, although I wasn't really invited officially, but I sort of sit in and listen to what they're saying. National Academies of Science and Engineering Medicine, they organize a small sort of like it's not really public closed, it's not really invitation only, but it's really small meeting where mostly magnetometer people attended and presented their work to be aware of the future needs of infrastructure for magnetometer magnetic field observations, especially for space weather monitoring. So there has been some discussion. So I'm just telling you that you know, not only just academia, but also industry are very much interested in investing you know, infrastructure for space magnetic field observations for space weather monitoring. So that's pretty interesting. We don't really know where to go after this meeting. This meeting is just to, you know, just promote like some discussion, not to make any like firm decision, whatever. But yeah, there has been some interest within the community as to where we should go from now on, given what we have in terms of magnetometer facility. The problem is that, you know, a lot of research-based magnetometer stations are, you know, short-term basis. So to be able to sustain the large network, we have to have some kind of consortium or some kind of like group effort to maintain this facility for space weather monitoring. So I guess that's interesting, and as part of this HAMSI citizen science-based magnetometer network. So one thing to keep in mind. So back to the Net.
Okay, very good. Next on the list is James, KG4 DSG. Go ahead, James.
You caught me debugging something. System will boot. Evening, Dave and the group. Not much to report here. I posted a couple of links in the chat if anybody's interested. Two alternative Raspberry Pis showed up in my news feed today. I hadn't heard anything about them. I haven't even looked at them yet. But neither one of them is $35. So bear in mind that prices are a little higher than what we're used to. With that, back to the Net.
Okay. Next on the list is JWB8 SBI. Go ahead, Jay.
Oh, hi, everybody. Nothing really new here of interest to this group. The only thing that I read about in the latest issue of CQ magazine that just came today, the December issue, was from one of the columns was a cautionary note about going on de-expeditions. That is, if you want to take your new bride on a de-expedition, go ahead, no problem. But well, let me rephrase that. If you're going on a radio de-expedition, I'm sorry, I misspoke. Don't take your new bride. Just go on the de-expedition and go on your honeymoon separate. Don't take her on a ham radio related de-expedition unless she's a ham. You do so at your own peril and risk. So that's in the latest issue of the December 2022 issue of CQ magazine in one of the columns. Other than that, take care, everybody. 7-3. Hope you all had a good holiday season, and we'll catch you later on down the log.
Very good. Next on the list is Jim K4BSE. Go ahead, Jim.
Good evening. Not much to report here. I've been a little bit under the weather the last few days. I'm probably not going to stick around too long this evening either because of that. Not because I don't like it, just because I'm feeling under the weather. Back to net K4BSE.
Okay. Next on the list is Jonathan KC3EY. Go ahead, Jonathan.
Hi, everybody. This week I haven't really been able to do very much, although there will be a transmission from SAQ on December 24th. So I will be preparing for that and making sure that it is not utilizing GPS for that broadcast, just in case something were to go wrong. The plan is now we are going to find the other GPS antenna and give that a try and see what's going on. There has been some chatter on the VLF groups. There have been some receivers, some VLF receivers in India, which are part of the ILDN, the Indian Lightning Detection Network. The hardware and the software was kind of spearheaded by Paul, the author of VLFRX Tools. And he set it up to, so normally it's set up to record spherics. Mainly time of group arrival data, but he set it up to actually record the 8.270 kilohertz amateur band. So it has been recording Bernd, who has been making quite a bit of VLF amateur transmissions. He was heard on the receivers in India. So that was really cool. And they were able to decode his EBNOT message. So this is pretty exciting. I'm going to see if his signal might have made its way over to my receiver, but I don't know. But what I would like to do eventually is, once I get this built, and now that I have a bench and my soldering tools and everything else, I don't have any excuses. I want to get my EBNOT rig built and working, and I would like to try to transmit some messages. These were definitely firsts. One of the receivers was in the Himalayan mountains. The students actually had to trek to the Himalayan mountains because there was an issue with the receiver, but Paul commends their dedication to keeping these receivers actually running. So they have that mind, that knack to keep these receivers running, and that's really good for students. And I hope that we can have that at the University of Scranton once we get some more receivers running. Other than that, I've been looking at ZFS as an alternative for storage. I would like to be able to store VLF data ZFS shares. So I've been looking at how to configure it in FreeBSD. The plan is to start with one volume, or at least one drive, which would be one pool, and just keep on adding drives to that pool, and adding some redundancy and error checking and all that. So setting that up is you would need some background on it before you could actually take advantage of it. So I'm reading up on that. Other than that, that's all I have. Back to the net.
Okay, very good. Next on the list is Michael, AC0G. Go ahead, Michael.
Good evening, everybody. I don't have much to report. My ham shack is in disarray for purposes of renovation, and so I haven't been on the air much or been doing much activity on my own here in the shack. A lot of other honeydews and such going on, but other than that, nothing to report. Back to net.
Very good. I will mention that Michael has an article in the upcoming Tapper PSR. The Tapper PSR is not out yet, but I have seen a draft of it, and his article looks quite good. Next on the list is Scotty, WA2 DFI. Go ahead, Scotty.
Okay. Can you hear me okay?
Yes.
Okay. Well, not much going on the Tangerine front here. Got the project that's blocking the way nearly done here. So it looks like that's going to free up some time for some FPGA fun here coming up soon. So that's all that's been going on here. Back to you, Dave.
Okay. And we have two Tom McDermotts. I don't know quite why. Go ahead, Tom. Did Tom send any kind of chat message?
No.
Okay, well, Tom showed up a minute ago. I think he's having computer problem or network problems again, because he appeared not to be in his home office.
I hope he doesn't have set new records as the person with the most failed Starlink dishes. I mean, this would be a second one if that's the case.
Tom, are you there?
It says connecting to audio.
There he is. We can see you. Tom, can you hear us?
It still says connecting to audio. There we go.
Hello, Tom.
Hi, something happened and Zoom crashed on Ubuntu and won't launch. And I'm trying to run it in a browser and it won't launch either.
You
Can you
have,
hear me?
yeah, we can hear you, but you have two instances of yourself.
I don't know. I don't know what's going on. I tried updating Zoom. It crashes as soon as I try to launch it. So let me go find a different computer.
You're okay right now.
Okay, I can't see any video from anybody.
Okay.
I can't see my own video. Can you see my video?
Yes.
Okay, I'm in the blind here then. Let's see, very, very busy week. Unfortunately, almost none of it on the project. I did get the SPI converter implemented in Verilog and integrated into the project. I haven't started yet writing the device handler. You can tell that the person who wrote the SPI block is different than the software person who wrote the I2C, because they they operate quite differently from one another. And how you register the app and get it started, totally different, use completely different calls to get things linked. So I've got to redo how the handler works for the SPI. And other than that, I'm trying to get a computer that works here. I don't know what happened. Zoom just would not come up and launch on this computer tonight. Back to the group.
Okay, well.
Oh, I had a question for Nathaniel. Nathaniel, on the documentation you're looking for,
Mhm.
do you want something that is more project focused or more technical focused?
Probably more project focused. This is
Okay.
something that's going to go to an NSF program officer.
Okay, so it's
So-
going to essentially a program manager?
Yes.
Okay, I'll go ahead and put something together that's got more project focus.
Okay, great. Thank you.
By the way, Tom, this is David, N1HAC. I don't think you were on when I was sharing, but I was able to implement the patch on the clock driver and
Oh, good.
confirm that the BIOS looks good on that.
Okay, yeah, it was, the chip seemed to be clocking happily as a result, so
Yeah, I
seems
was
like
seeing-
it's a good fix for now.
Yeah, I was seeing 1.8 volts average voltage and 1.1 volt peak to peak on each side.
Oh, great, that's good.
What you were seeing.
Good, good.
Well, we did have Dylan in 6 IVW jump in there. I don't know if he has anything to say.
No, I don't have anything else other than we're closer to finishing up in California and getting back to Tennessee. But other than that, I'll send it back to net control.
Okay, very good. I
Oh,
think
real quick.
that's, yes,
How is my audio?
we can hear you fine.
Okay, so it's the truck then.
Yeah, it's a lot better than usual.
So I believe I've called on everybody on the list, so we should be open for general discussion.
There was a couple of things. First, Jonathan reminded me I actually finally got my VLF loop up and running, which was a problem on the last SAQ transmission. I now get NAA 40 or 50 dB above the noise floor, so looking forward to giving SAQ another try. The other thing is that in putting the development board adapter onto the Max 10 board, there's a little bit of a clearance problem with the power connector. I was able to heat up the 2 ground pins on the power connector and shift it over just a touch. But without that, it was straining the connector and a little hard to get the mounting screws in. So I don't know if you noticed that, Scotty.
Yeah, I did notice that it was very tight, but on the several boards that I've had here, I've been able to plug them on without any trouble. And maybe a little bit of filing on the board would work.
Yeah, I
or-
wasn't sure how
like
close
you-
the ground planes were, so I didn't want to go filing
Yeah.
away until I asked.
Yeah, I managed to get them put together, but it does brush right up against it. So
Yeah, it was very tight on mine. I had to move things. But
I was
works.
able to get mine together.
Yep.
Tom's trying to talk. Tom, you're muted.
Okay, I just installed the latest Zoom and rebooted the computer, and it was kind enough to tell me Zoom had crashed, but now it's working.
Well, very good. Did you get to hear that Dave got the modifications made?
Yeah, I heard that, and that's good news. It sounds like it's it's a fix we can do on the current Rev A boards, and will work for everyone who's got a Rev A board. So that's encouraging.
Good.
I'm trying to think of what else happened this week. It was frightfully busy. My Starlink, I got the second brand new kit, new dish, new modem, new cable. It made it 10 days before it failed. And so last week was going through the copper mining phase of getting version 1 boxed up and shipped back to Starlink. And I finally have had enough fun, 4 modems, 3 cables, and 2 dishes. And so I canceled the service on Friday. And I spent Friday crawling through the attic, pulling RG59, and I have a cable modem now. So I've got cable internet.
Well, sounds like that might be more reliable.
It would seem apparently not likely to be less reliable.
Well, I do
Why-
know that you live in a bowl there in Southern California or Southern Oregon.
Yeah. Yeah, it was, although I've got unobstructed, the sky is completely unobstructed where I'm located. So when it worked, it was great, but I think they have some kind, perhaps design issue with the product. So that just, I don't know what it is, maybe a power supply issue, but certainly 10 equipment failures is a lot.
Yeah.
Why are there so many equipment failures with that?
I have no idea. No idea at all.
That's
So
so strange.
Nathaniel, are you still using yours?
Yeah, I've still got my first one. So far it's been reliable. So knock on wood.
Yeah, I put monitoring on it and it was going up and down. After 6 days, it started dropping out intermittently. And after 10, it completely dropped out. So there were lots and lots of outages after about day 6.
Hey, Tom, it looks like Tesla likes something that Nathaniel's doing. So you should probably watch his life and see what he's doing. Copy
Yeah,
that.
he's
I don't
in their
know.
good graces.
I don't know what Tom can possibly learn from me about networking. That is all very confusing to me.
I find data networking to be a bit arcane. Telephony was more straightforward.
Tom, the dishes they sent you, were they the 2nd gen, the square one, or was it the bigger round one?
It was the 2nd gen square dish.
Okay, so that one may be having the problem.
Yeah, I'm not sure. You know, they're what the indoor Wi-Fi modem does is it's got a 48-volt power over Ethernet injector, but it's not standard PoE. I think it's capable of more current and more power than a PoE++ injector. I'm not completely certain, but I think the indoor unit's capable of supplying quite a bit of power to the outdoor unit. All the brains are basically in the dish, not the indoor Wi-Fi unit.
Yeah, there was a teardown video I saw months ago where somebody probably shouldn't have done it because it probably wasn't owned by them, but they dug into the first dish, and the engineering inside of that is impressive.
Oh yeah, it's an amazing technical accomplishment.
And it's well, at least at that point, it was one printed circuit board. That big round dish was one piece of printed circuit board.
Yeah, and it's got lots of circular patch antennas.
Yeah.
And they showed the stack up of the board to build, what is it, 192 elements or something like that phased array antenna. And the board does all the planar to circular mode conversions in the circuit board. It's really impressive technically.
It's something you find on the front of a fighter jet.
Pretty much.
Maybe you need a Twitter account in order for it to work.
Yeah, maybe. At any rate, so I canceled the account on Friday and got cable up, and so hopefully I'm back. And Zoom came up after rebooting Ubuntu, so I guess I must be in good graces for a while.
Good.
What's the download and upload speed on Starlink?
I was routinely getting about 170 down, and up would be anywhere from 6 to 50, depending on time of day and usage.
Oh, interesting. Yeah, for cable, I'm getting 11 upload, which is, I wish they were less asymmetric.
Yeah, I just test, this one I've got is a DOCSIS 3.1 modem, and it's getting about 380 down, 360 down, and about 11 up.
Yeah,
Sometimes 12, sometimes 10.
that's what they give us. What carrier is it?
Comcast.
Oh, okay. Yep, that's them.
Yeah, the service is called Spectrum.
Oh, okay. Yeah,
Like
they call it
Comcast.
Xfinity here, but it's Comcast.
Okay, I think Comcast is the owner of Spectrum. I'm not,
Right.
I could have that mixed up with something, but I think that's it.
Yeah, they just refuse to give us good upload speed.
Yeah, I don't know if DOCSIS 4.0 will give more flexibility in the upload. I'm not sure how that works. I think DOCSIS 4.0 has been approved, but has not been widely deployed. I suspect the cable operators have to do some plant modifications to make it compatible.
Right. But
The last couple of months, I've had T-Mobile 5G, and it works pretty well. It's not fantastic, but it's good.
Yeah,
The speeds are fairly symmetrical. So I get about 170, 180 up and the same down.
that's pretty good.
That is really good for the up. So the only issue I've had with it is it goes off between about 2 o'clock and 3:30 in the afternoon for about 5 to 10 minutes, almost every day. It's absolutely bizarre.
Wow.
So other than that, it's been decent.
Yeah, we had a T-Mobile wireless tower. Unfortunately, it's on the other side of a mountain from me.
Oh,
yeah, we have some severe network discrimination in this area, in that if you live in New Hampshire, you have to put up with Comcast and their slow upload speeds. If you're in Vermont, they have independent fiber, and they are 1 gig both ways. And the people who live in Vermont don't understand that we don't have that service.
Yeah, we have a couple of local carriers here that are very good and much more symmetrical, but they don't come quite this far east, and so they won't put in service to places that have underground utilities because it's frightfully expensive to do that.
Right. I actually had a power failure the other day that just was the fuse up on our pole. And I share the transformer with my neighbor across the street, and they have underground utility, underground to the house. We never did find the short. It just kind of cleared itself after 2 fuse replacements. I expect
that's the brute force.
The squirrel let go. The squirrel had enough. He just let go.
Yeah, it wasn't a squirrel. It would have been a mole. But yeah.
Well, either way.
Well, I think it was a good idea putting in a bigger amperage fuse each time you change it, so that
Yes,
50 amp fuse in there now should hold.
Were there any trees or other rooted plants glowing in the dark?
No, couldn't see anything. I was out with the guys when they were working up on the pole. They put a new fuse in, held for about 20 seconds and blew out again. We went searching around, looking at everything, couldn't find anything, and then tried it again and it held.
Well, I had, when I lived in Texas, had underground power feed from the cable. And one time I had the neutral burn open.
Ooh.
I had the two hots.
Oh, yeah.
And as long as you, your house is drawing about an equal amperage from the two hot phases, it'll kind of work. But I was getting this case where I'd get one side would go down to 70 volts and the other side would go up to 165 volts. And finally, I called the utility. They came out and said that, you know, the power lines are supposed to be buried 4 feet underground by code. And the contractor who had put in my house in 1971 had managed to get it 9 inches down. And there was a fence post right underneath where it was. And that fence post had managed to work its way through the neutral line.
Oh, dear. Well, I had a big instance of that when I was working at New England Digital. We had moved to a new building, and we were in a big growth phase at the time. So we kept adding more and more equipment, including things like wave solder machines and such.
Oh, boy.
Things that would take lots of power. And one summer, all of a sudden the lights started flickering. And my office was actually turned out, it was on the end of the building where the power came in. And I saw some fireworks going on. And what had happened is the ground wire and one of the 3 phases had welded together and then opened up.
Oh, boy.
And yes, some of the lights were on, but I just knew exactly what was happening. I ran down in the basement, pulled the main breaker. The vice president comes running down and say, "What did you do? We still had some lights." I said, "No, you didn't." And not only had that happened, but the transformers were boiling over.
Yeah.
They ended up doubling everything and didn't have a problem again. So it was really whatever was running was bridged between 2 hot phases of the 3 phase.
Mhm.
And the ground and 3rd phase were open.
I have a question. I'm pretty proficient in CAD and all that, and I was curious if you guys would want a enclosure made for the Tangerine.
Thumbs up from here.
Yes,
Okay.
definitely.
Okay. So if that is the case, would you be able to send me one so that I can measure it and build the case from that?
I could start out by sending you all of the documents and followed by a physical unit.
Okay.
So you could see, you could get all the measurements off of CAD. Can you take trying to think what our CAD guy could produce, because he could produce a 3D model of the board stack with everything all. So it's
Have we figured out where all the ports are and how they're going to get?
oh yeah, all the connectors and everything. Or so
Yeah.
what he does is when he puts the 3D model together, he puts the connectors on the board so we know exactly where they are and where they stick off and how much
Right.
they stick off and all that.
Yeah, well, you certainly could send the 3D models of the boards.
Yeah.
Yeah, so long as there's measurements on the pages or the documents, I can map all that stuff out. But if you have a 3D model for that, that would work perfect.
something you could import would be the best, right?
Yes,
Yeah.
but I can make a design off of measurements too, if necessary.
Okay. Well, can you give me your email address or put it on the chat?
Yes.
I will drop you an email with the good stuff in it.
Okay, there it is.
Okay, got it. Thanks.
Actually, Scotty, that raises a question. Do we have any idea what kind of thermals we're going to be dealing with yet?
No,
Okay.
but we have set it up for see if I can get this right. We set it up for airflow down onto the top of the top board, because the daughter cards that stick on top of the top board, the leaf and the clock module, do not have any heat generating components under them. So if we can get airflow directly down on the top of the board, and then we just have to make sure it gets directed along the RF modules along the bottom to be and out one of the sides or the one of the ends, then I think we'll be okay. So we'll need, it'd be more like a pancake type arrangement, a thin box with fan in the top or a fan in the end. And you know, I've seen you maybe make them 30 millimeter fans and put 3 of them or so all blowing across in one direction with slots on the other end, and then you get flow over the top of the boards.
Yeah.
And that because we only have IO on 2 of the 4 sides. So we actually have an SD card on the 3rd side, but the RF module side where they plug in has no IO at all. So we can blow air in that side or blow air in the other. Well, you can't blow air on the other side because it's got all the RF connectors on it. So that's pretty well all occupied. And the left side is where the power comes in, and the clock module and the GPS antenna and, you know, all that stuff comes in. So that's pretty well the entire side's taken up. But the right-hand side just has the SD card, and I don't believe there's anything else that protrudes there. And then the bottom side has nothing. So we have clearance to put fans in there.
So this thing generates that much heat? Or just in case?
Just in case. We never did a thermal analysis, but we tried to make it possible to cool it to some degree at any rate. And it doesn't really produce that much heat, because I mean, realistically, you can tell how much heat the thing's going to produce by measuring the current, the power going into the box, because essentially all the power that goes in comes out as heat. We don't, it's a great heat converter. So, and you know, I have not plugged everything together and fired it up because it's going to depend heavily on how much FPGA loading we have. The heavier duty the FPGA, more work the FPGA is doing, the more power we're going to draw. The A to Ds will be relatively constant, and they'll be, you know, because they run at a constant speed, and it won't matter what the data is coming in. It'll be just whatever the current is, the current is. But the FPGA depends on how many flops are clocking at the same time. And so as you add more and more logic to the FPGA, you consume more and more power. So.
And then real quick, you want to you're saying that you want to add a fan on the top, or were you saying that you want to add fans on the side?
Either on the top or on the end, whichever.
Okay.
Sure, makes most sense. Depends on how thick the box is, because if the box ends up being very thin, little bitty fans are notoriously inefficient, so they don't work nearly as well. And on the top, there's nothing that comes off the top. And the thing's about 110 millimeters square. So I mean, you can put a giant fan on the top, and you know, have a hovercraft lifted off the desk if you want it. And I don't really think we're going to need that much on the IQ2, which uses a bigger FPGA. Actually, the fan that we use is a 20 millimeter fan, I believe. Little teeny thing. I mean, it's an inch square, and it moves, I think, 3.7 CFM.
Jeez.
Nothing. You can't even hear the thing. Okay, but turn the fan off, and the box overheats. So it just takes just a little bit of air and it blows right in the top, right on the, we put a stick on heat sink on the FPGA, which we will most likely do when we put it in an enclosure, and then blow the fan right on the heat sink. And then provide slots to direct where the air goes after it comes off the heat sink. And so that's what we did on the IQ2 is we enclosed the entire thing except for the fan inlet and the outlets, slots of outlets on the far end. And then we made sure the boards came very close to the edge of the enclosure so that the air really had only one way to go. And it had to flow down across the top board and it couldn't go to the left. So it went to the right around the end of the top board and then back along the bottom of the bottom board to the vents on the bottom. And so very little bitty amount of airflow, but it was just enough to keep everything cool.
Yeah, and receive it uses about 10 watts.
Yeah, so 10 watts, that's a goodly amount of power for such a small enclosure. But it's not excessive.
One more thing also, do you know the size of the heat sinks that you're planning on using too, or is that not yet decided?
We don't have any heat sinks on the boards, I don't believe. I don't remember. It's the because we're using
if not, it's fine.
We're using the data engine adapters, which I don't believe have heat sinks on them. Dave and Tom, do you remember, is there a heat sink on that FPGA? I don't believe there is.
On the development kit, there are no heat sinks on the development kit, data adapter, receiver, or clock.
Okay.
I don't know if the FPGA is going to really need one or not. I think the receiver may not, but I haven't gotten to the point where I'm clocking that ADC yet.
Well, I think that the ADC on the receiver board likely would just need a little bit of airflow to keep it cool and maybe no heat sink. And the heat sinks will end up, if we're going to use them, they're going to be maybe 8 millimeters high, thick, the height of the fins, maybe 10. So not very high. And the FPGA is about 30 millimeters square. So we use probably something a little bit smaller than that. So, 25 millimeters square and 8 or 10 millimeters high. And we'd use a self-adhesive type that just sticks on top of the FPGA. Not really super efficient, but we don't need a lot of efficiency. We just need just a little bit more cooling.
I don't have quite long enough a cable to get a good view of the development kit here. There it is.
Yeah. Well, is the Raspberry Pi or whatever the host is also in the box?
No.
How does it connect?
Network.
Ethernet.
Oh, only by Ethernet. Okay.
Right. So we basically have the two RF boards on the bottom, the data engine in the middle, the clock module, and the leaf module on the top. So it's a 3-board stack. So it's probably, let's see, I'm trying to think what the clearances are because we have less than 10 millimeters between each of the boards. And I think less between the RF modules and the data engine. However, the backside of the data engine and the backside of the RF module, which are next to each other, have no components on them. So there's no need to really have any air blowing in between the boards other than to cool the core of the board itself. So basically you've got the main generators of heat, the A to Ds and the FPGA are on 2 boards that are stacked like this with the RF modules on the bottom of the bottom board and the ADC on the FPGA on the top of the top board. Did I get that right? FPGA up here, ADC down here, and then the clock module sits on top of the data engine in a little corner that doesn't have any components under it.
All right, let me see if we can.
Yeah, there you go.
Yep.
Yeah, so that's a much more spread out view of things, but you can see how the clock module does sit right on top of the board. And there's nothing underneath that clock module.
So there's the clock module.
So if you can imagine, and you can see where the RF module is on the left-hand side there, that's underneath. So getting air through around that connector might be a little bit of a problem. And the A to D converter is on the far end yeah, right there where Tom's pointing. And the connector is right on the other side of the board there. So, but the thing is, you really don't need to get any air in between the boards because there aren't any components there. So the connector can block all the airflow, and that's fine. You want the air to flow the way Tom's got it now. You want the air to flow over the left and the right of the two boards, and that's where your heat generating components are.
Well, I think what I can do with that is a way to solve that is basically creating positive pressure within the case. So then more air is going into the case rather than exiting. And
well, don't get too far ahead on that one. That's not the actual.
Yeah, that's not the actual board set. That's just an example. When I send you the
development system we've
when I send you the drawings, you'll see what it's really like. And the thing is, whether we come in the top and go out the bottom, I think it doesn't matter. But my envisioning was two small fans on one end blowing air across with slots on the far end, and that way the air really has only one way to go. It's a positive pressure in the case, and there's only one opening, so it comes out there.
Yep.
And the end, the end that it comes out would be the end that has all the RF connectors on it, all the SMAs. So that makes it a little easier. You don't have to try and fit the SMAs and make a tight seal around them or anything. You've got lots of slop there because that's where the air is coming out anyway. So, and really the RF module, when you put the fans on the connector end, the ADC is right at that same connector end, and there's virtually nothing that generates any heat on the rest of the board.
Yeah, Scotty has some drawings of what the real thing looks like. This unit, we had to get a development kit board rather than the real base board because that's all the parts we could find a year ago. And so this is kind of, Scotty's got some good drawings of what the real thing looks like. It's a little bit different than what I showed you.
Yeah, let me show you. If I can find it here just a second, I will, I can show you a drawing. And then, when you see the real thing, it'll make a lot more sense.
Yeah. And I got one more question just for the production side. Are you going to, is it sort of just gonna be something where if you have a 3D printer, then you can grab the file from the HamSci website and print it yourself? Or is it gonna be something where you guys produce it and then sell it as an extra?
We prefer to have it made out of metal. So
metal, okay.
Kind of hard to 3D produce. If it's plastic, then we should make it 3D printable files if we could do that. I have no problem with it.
I could do both.
It's kind of big. It's over 100 millimeters square. So I don't know. I'm not really much up on 3D printing, but that seems to me 100 by 105 millimeters is 4 inches square is a little bit large for a lot of 3D printers. The big flat areas seem to be hard to print.
I've got a 3D printer that was about $500. They have a cheaper one that was about $300. And my 3D printer that I have, it does 200 by 200 by 300 millimeters.
Okay.
And then the cheaper one does 200 by 200 by 200, I think it is. So a lot of the cheaper printers are, they are bigger. They don't have as good quality, but they do have the size to print something that big.
There are reasons to go with metal, though, both heat and shielding.
Yes. And if that's what you guys are planning on doing, I can do that too.
Okay, let me share my screen here. I can do this. Hold on.
Though to be fair, they do plastic. You can spray conductive material on plastic and shield it.
Okay, can you see this here?
Yes.
So this is a top view basically. So the blue down here at the bottom are the connectors for the RF modules, and you can see the dotted lines that go up the middle here. And then the RF connector sticking out at the top. So those are the RF boards, 2 of them that mount on the bottom of the data engine. Then the clock module in green over here on the left mounts in a corner on the top of the data engine. And then the leaf board mounts, it's a red orange board here that mounts on the top. And there are some components underneath this board. This is problematic because this is where the power supplies are. So these are the other heat generating pieces. So, but in the beginning anyway, we're not going to have a leaf board to start with, but the VLF module is probably going to be the first leaf board that we're going to put in the system. So you will have, it will be nice to put some air underneath between this board here and the data engine. And the heat generator on the data engine is this max 10 part right here. So you can see if we were to put 2 fans down here, and I would blow air right on the connectors because the connectors will be a great way to block the air from going in between the boards, and it will go underneath the RF boards, which is where the components are. So you'll get airflow across the top surface. Well, I guess the bottom surface of the RF boards, which is really the top surface because the RF boards are mounted upside down. So they're back to back with the data engine and underneath it. So does that make sense?
Okay.
So there's
Yeah.
in between the blue boards here and the data engine itself, there's no components, just bypass caps, nothing that generates any significant heat. So if you want, you want to blow the air over the top of this board and underneath the blue boards here and exhaust it up here.
Okay. Yeah.
Scotty, your cursor is a little behind your top.
Oh, okay. I was moving it pretty fast, wasn't I?
Scotty, what is the outline that's marked RPi hat?
The orange outline right here,
Yeah,
that's the size of a standard Raspberry Pi hat board. But our leaf board is bigger. It extends to the left here.
right. But
And extends to the M2 connector. So if you
but
want
is
to,
there an RPi there?
no, it's a hat outline. So if you wanted to plug a Raspberry Pi hat board, a standard hat board, like some kind of sensor board onto that connector, that's
Oh, I see. It's going the other direction.
yeah.
So
So you can
it's set up so you can plug an RPi hat on it,
right. And
like
so
our mag or whatever.
make it take either one. And if you use our outline with the additional M.2 connector, you get some high-speed I/O, and we can use that for the VLF module.
Right.
So, so that's probably the best picture I can give you. And you can see along the left side here, all the connectors stick out the left side. And across the top are the RF inputs. And then on the right side, nothing. And I believe if I remember right, the SD card, we have a micro SD card on the data engine, and I think it sits right in here, but it is completely enclosed inside. So you may have to put a slot here for it if you expect to take it out with the enclosure in place. My guess is that it wasn't designed to hang over the edge. So it will be something that you plug in and then put the enclosure together. If you want to get to this micro SD card, you're going to have to take the cover off, which is maybe not the optimum, but it is what it is.
I mean, if it does sit in there a little bit, you could probably grab something thin to, you could still have the slot there and then just push it in with something that can fit through the slot, whether that's something that comes with the kit or.
It's actually right here underneath the leaf module. This is the layout of the board, of the data engine. So it's right here on the right-hand side.
Is this is the same orientation as the other photo?
Yes. So you can see the two
Okay.
connectors
Oh,
here,
yeah, nice.
RF modules, right? And you can see the blue outline up here where my cursor is. I don't know if it's caught up, but the blue outline, and there's actually an orange outline, which you can see kind of curved here. That's the Raspberry Pi outline, the hat outline, and the blue outline is for our leaf module, which is a superset of the Raspberry Pi. And it really only changes down here when you get down to this M2 connector. down here where my cursor is now. Where Raspberry Pi hat goes straight across, we have a tab here that plugs into the M.2 connectors to get additional signals.
Okay.
And this is interesting because it shows the clock module like this, but I believe the clock module has the notches here and it comes down like this. So this outline is of the old clock module, even though this is the current data engine. The clock module is not shaped like that. As you know, it's shaped like, as soon as I find it. Okay, you see there's a notch here in the clock module in the upper right corner. And again, this is kind of irrelevant to you because this stuff is all mounted onto the data engine. But that notch, oh, where did it go?
Sorry, I forgot I was muted.
Oh, okay. So did you see where the notch is here?
Yes.
And that goes right in. That notch is used to go around this header here because the board's actually wider here. And it goes over this part, and I believe that's just a USB part. It generates very little heat. The FPGA, of course, being this guy, this big guy here. So getting airflow across the middle of the board from bottom to top would be what's important. And these three things, these up here, these 4 parts, these are the power supplies.
Scotty?
Is there any chance that we may need to put a heat sink on top of the FPGA if it's really busy?
Yes, we will. I think so.
Scotty?
Yeah.
Do you have a micro USB on the data engine to talk to the GPS?
Well, it's hooked to the FPGA.
Okay.
So we can use it to store data to talk to the GPS. We're not going to put a file system on it or anything like that. That gets too complicated.
Yeah, the reason I was mentioning is because I had to use that to configure the GPS on the data engine adapter. That USB does not connect to the FPGA.
The USB on the
clock module does not connect to the FPGA.
That's right. It connects to a USB port, a USB connector right on the data engine adapter.
Right, and that is an extremely handy place because you can use the uCenter software to talk over that interface.
Right. Now we bring that on the data engine. We do the same thing. We bring that out. You can see, I believe, let's see, where is it? Blah, 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 blah. There is a micro USB right here.
Okay, good. So there is one on the data end. That is just super convenient to have.
Yeah, it can actually, the USB connection from the GPS is brought out to this M.2 connector and connects to the connector on the board. So
right.
Yeah, I think that John wanted that because you can use like you said, the software. You just plug a PC in there and use the software as is to configure it.
Right. Okay, good. There's, besides configuration, there's all kinds of monitoring and other things you can do that will help you troubleshoot.
But can't you, everything you can see over that USB, can't you see over I2C?
No, I don't believe so.
Okay. Those are the kind of things we're going to learn, because I thought it was, when John and I were talking, he says, well, either port's fine. You can use the I2C or the USB, but the USB will just plug right into a computer and you can use their software, right?
Right. So far I haven't gotten the I2C to talk to anything. So I don't know what that means. Okay. But the I2C is really more message oriented, and it might take commands, I'm not sure. Until I can talk to it, I won't know. But having the USB has, helped get around a bunch of issues there.
Okay, so are you using the USB port on the data engine adapter?
Absolutely.
Okay, and it's working okay?
Yes, I have it hooked to a laptop that's running uCenter, and I was able to go in and configure the chip to come up and set the time pulses to the correct frequencies, to lock onto the right satellites, to make some configuration changes on I2C, which you can't do when you start up the I2C.
Yeah.
And so far I've not been successful talking to I2C. So having that micro USB was, invaluable in getting all this up and running.
Okay. Well, good. We tried to think of everything, but we don't always think of everything.
Yeah. So if that comes out on that board, people will probably want to plug a micro USB cable in there. So if that's on the side where you've indicated, that's a good place to put it.
Yeah, this over here, you mean?
No.
Or over here,
That's-
okay, the micro USB. Okay.
Yeah. So it's on the same side as the Ethernet and the other connectors. And so you'd leave a slot in the box to be able to plug a micro USB in there while it's running.
Yeah, now let me, before I get you too excited here, let me make sure, because that's the USB 3 connector. It's got the two halves, the high speed and the USB 2. That
Okay.
I don't think that connects to the G clock module, because that
Okay.
goes to that's this chip over here. It's a USB 3 chip. So I'm going to stop sharing here and I'm going to go look to see how that's connected.
Okay.
So, before I give you wrong information here. Yeah, because I know we had a lot of different uses, different connections for the clock module. I know the USB comes to the connector. So
Yeah, it does, because on the data engine adapter, the
It comes
clock
out.
module talks through that connector
Right.
down to the drive electronics and micro USB on the DEA.
and I wouldn't have done that on one and not on the other. I can't imagine I'd be that silly.
Okay.
So,
But it's just, if it's in the middle of the board and vertical, then we'll have to look at ways to get a cable and connector in there in the box.
yeah, so here, I can share this with you. If I can find the controls, here it is. Yeah, so this is the connector on the data engine for the clock module. And you can see it runs over to a USB connector right here.
We're seeing a code, not a graphic.
Oh, wrong screen. Hold on. There, that might be better.
Yes.
So you can see this is the clock module connector, and there's a USB connector connected right to it. So, and that is a vertical one, so that's in the middle of the board. It's not going to come out the edge.
Okay.
So you have to have the cover off to do that.
That might be okay.
Let's see, it's J7. So not there. Trying to find. So this doesn't have all the ref deses on it. So I don't know where that connector is.
Is it on the back side of the board?
No, there's nothing on the backside.
Okay.
Let's see, 1 second here. Get Rev PCB PDF. Composite. I think this is the drawing. Well, that didn't work very well. That doesn't show you much, does it? Oh, it's still rendering. This is a full stack up of the whole data engine, so it takes forever to load. It's actually a layered PDF, which is, I don't know how he creates this, but is amazing drawing.
Okay, I did a search of the PDF for J7 and it says not found, except I can see J7. It's right behind the vertical sideways mounted, gee whiz. Okay, the
So it's right in-
Rev-A data engine looks different than the drawing you have.
Yeah, and that's quite possible because this is a preliminary version.
Okay, so if you see that thing marked RC, it's the vertical. If you go to the Ethernet connector, go right below it. There's a vertical mount.
Right
USB.
here.
Yeah, there it is, right there.
Right here.
No,
No,
it's to the
right
left.
here.
Yeah,
It's
that's it.
Right to the left of it. Yeah,
GPS
that's it.
USB is actually labeled. So
Yep.
it's straight up right behind the USB 2 connector.
Yep, that's it. Okay, so it's there. That's good.
Yep. And then there's actually a connector down. I think it's down here. Anyway, it's an MMCX connector, and you can actually get the like clock 10 off of the clock module, one of the ones that we don't use. But if you want to use it as a reference for your other stuff in your system, it comes off down here somewhere, I believe, because the clock module is, it comes down like this. Here's the connector for it right down here.
Okay. The reason I bring all this up is it may be necessary to have the fan running and cooling the data engine and other board while you have a cable plugged into that GPS connector.
Oh, I see.
And so it's a consideration in the box that holds everything that you can get a cable plugged in there while the fan is still blowing air in the right place.
So if you put two fans down here, the problem will be is if you take the top cover off, you're not really going to be directing the air across the FPGA then.
Right. And so what you'd want is a slot in the side where you can route that, just the thin part of the cable out through the side and put the
So
top back on.
Slot over here somewhere.
Yeah, exactly.
Yeah, it's going to be problematic because the clock module comes right up to the edge and it runs right along here. You maybe get out between the Ethernet and the USB 2.
Yeah. Anyway, it's a thought. Yeah, if you're going to put it in a box, you're going to need to be able to get that cable out while
And
the fans.
that also kind of begs the question is how much clearance above this board are we going to need?
Yeah.
And I think adding a little bit of clearance, making the box thicker would allow you to run the cable around and over here or wherever you wanted to route it.
Yeah, so okay, this is the micro USB cable
Right,
I've
but
got.
you can get a right angle version of that. So
Oh, you can?
Yes, you can.
Okay.
So that might be the way to do it. So it may be a generous height on the top of the board, and then we can use a taller heatsink on the FPGA also. So, and actually, you're going to have it tall anyway, because this Ethernet 1 here, this is a double stack of RJ45 connectors. So this is, easily over an inch tall. So that's the tallest component on the board.
Yeah, so that may be adequate.
Yeah. Yeah, I mean, it would have been nice to put that connector so you'd have access to it, but there was just no way you could do it.
Yeah, so the micro USB that I have, that double stack Ethernet connector is not tall enough to clear the cable.
So you'll have to have the box taller than that Ethernet stack then.
Yes, or you have to get a right angle micro USB.
Yeah.
Yeah, that double Ethernet connector is almost exactly an inch tall. There's one on the max 10 board. Yeah, it's exactly an inch.
I guess the other possibility is to put a access hole in the cover and a snap button that you can put in the hole if you don't have a cable plugged in.
Yeah,
with Micro USB.
That's a perfect way to do it because you can put the hole, make the hole big enough, you can snap the plug out and plug it right in without having to take the cover off.
Right, right. So that would simplify the engineering a lot.
So Dylan, have we given you
If
more
you-
information than you want to ever hear?
I would say not enough.
Okay.
I do have one more question though. So I'm just curious on what type of heat sink it is. If it's going to be like a finned heat sink, or if it's going to be the post type heat sink.
I can show you an example on another board. If you can, I don't know if you can, let me turn off my, just a second. Let's see. Okay, how do I turn it off? Oh, I just do that.
I just have your video screen share, not screen share.
Oh, right. So that's not going to help any.
I have it pinned, but oh, there.
Now, if I can just turn off the background. Background and effects. None. There we go. Now you get to see my ugly shop.
I think it looks beautiful.
Okay, so you see the kind of heat sinks I'm talking about?
Okay, yeah.
There's really big ones over here. And then this is an FPGA also, and it's got a relatively, I don't know if you can see it, a relatively small one. It looks kind of like a joke because it's so small, but it really hardly needs any airflow at all. So that's why I picked that one. We'll pick one
And
almost the size of the FPGA, but about the same height.
I don't know specifically what they're called, but that's what I was thinking of with the post type that I was talking about.
It's an adhesive attached type. Uses like a Berg stick or something to thermal pad, and you just peel it off and stick it on.
Okay.
And they work pretty well. They're of course they're not as efficient as ones that you glue on or whatever, but they do a pretty good job because they get plenty hot. So a little bit of airflow goes a long way over one of them.
Yep.
Like I said, I know we had 3.7 CFM of airflow in the IQ2, and it seemed like it couldn't possibly do anything because it was so little, because the fan was only, I mean, it was that big, but it was enough. And it only has to be enough.
Okay. Well, that should work perfect. And I think you sent the email or not yet?
Not yet. I have to find out. I may have to go back to our CAD guy and have him create the okay, I'm having a brain fade here. What normally a 3D drawing would be in what kind of, what program?
Oh, really it doesn't matter for the model so long as I can get it in there with
he can produce it in what the really common format is that everybody uses.
Either S.stl or .obj. Those are the two.
Okay, and what's the program that you use to?
I use Fusion 360, but so long as he puts it into an STL or an OBJ, I can put that on my thing and use it to create my enclosure.
Yeah, and I forget what the name of the program is. You know, when I have a viewer here somewhere for it.
Are you thinking of the DXF format, Scotty?
Not AutoCAD format. It's what is the common CAD program that everybody uses nowadays?
I think I can pull DXF up also because
I know we can do DXF, but when we do when we
SolidWorks or AutoCAD?
It's SolidWorks. He can generate SolidWorks files.
Yeah, SolidWorks I don't have But
It's
you-
a standard
if-
format.
But you need,
if it
Oh.
does come in a AutoCAD file, I can do that because AutoCAD is made by the same people as Fusion 360.
okay, is that Evolution Computing?
Uh,
No, that's
Autodesk.
Autodesk,
Autodesk.
right.
Yeah.
So I get it confused because I know one of the guys who founded Autodesk, so. Anyway, so it's, and what's the other one? ODF, you said?
OBJ, STL,
OBJ
and
and
OBJ.
STL. Okay. And DXF. I'm sure he can do at least 2 of those, so. Yeah, because I know when we were building the stack, we had really concerns of how it was all going to plug together and whether it was going to plug together. And of course, on the bottom of the clock module, we do have capacitors, and some of the capacitors are pretty large, and we have capacitors on the data engine. So we don't really have any heat generating components, but we have 2 elevations that have to merge together, and the caps can't hit because we only have like I think 6 or 8 millimeters between the boards. So, and some of those big 100 microfarad capacitors are 10 millimeters high, so you can't put them on the back, so you have to put them on the front. Or if you have 4 millimeter ones, you can't put a 4 millimeter one facing down and a 4 millimeter one facing up and get them within 6 millimeters because they will hit. So we had to make 3D CAD models of the boards, rotate them and place them in the place that they were going to actually be mounted on the together, and then check all the heights of all the components. So every CAD component that I gave him to be mounted on the board has a height property. So they all, then that's the only way we could guarantee that the boards would merge together and not clash, not physically interfere, so that you couldn't mount them together.
Yeah, and that would work perfect.
So, yeah, so we have, and so then what we did is we took all of the outlines of the 4 boards, and actually put them together and you know, at the proper height. So we can see, so we can actually turn the boards like this, and we can look in the edge and we can see whether there's going to be any conflicts. So it's pretty amazing that what you can do nowadays. But what you really need is the 3 boards put together that you can rotate around, and you can take dimensions off of, right?
Yes. And if it's really needed and the power supply does need more airflow, I could try and work something out to create a baffle to push more air in towards the power supply. So all of that is really depends on what you guys need. So
yeah. And I'm thinking, if you know, if the power supply, let's see, am I still sharing? I guess not. Okay, and where did the thing I wanted to share go? There it is. So if we were to put the fans on this side, for instance, seeing that we don't need as much airflow over here.
I'm not seeing your screen. It's still on the
my screen was paused. I don't know what that means. How about now?
There we go.
Okay, so if we put the fans here and here, and then we put the outlets here,
yes,
the air is going to have to flow over that area of the board to get out.
Yep, that would work.
And there's really nothing, I guess I shouldn't say that, because there's a power supply chip up here too, because we use a 2-stage power supply. So we regulate the 12 down to 5, and then we regulate the 5s down. So we kind of spread the power dissipation over multiple regulators. So probably this is the most power intensive one up here, U1, right here where my cursor is, if you can see it.
Yes.
But it's not very power intensive because it's a switch mode regulator. So I don't think there's nothing on here that really dissipates a lot of power, except maybe the FPGA and the A to Ds.
Okay.
You see our fan connector right here?
Okay, I was just about to ask. I was like, is there any way to power the fans? And
yep,
never mind.
We have just one connector, so you'd have to parallel them or, make a harness for them if there's more than one fan.
Do you, how much power is it able to put out?
That's a good question.
The max voltage, amperage, and all that. Let me write this down so that if we need more.
I don't even remember where I put the fan. It's controllable, and it is a 5-volt fan. And you get 250 milliamps at 5 volts.
Okay,
I
so
don't know if you can see this on the screen, but it's right down here at the bottom.
so
Probably pretty
so it's
small to see.
5 volts and 250 milliamps.
Right. Whoops, right there.
Okay.
And I can tell you that those little bitty fans don't draw anywhere near that. The
250.
They draw like 50 milliamps a piece there because they're so small. They're just really microscopic.
Which gives us room if we need to add a couple extra fans.
But they will have to be 5 volt though, but 250 mils. And actually, you could probably consume a little bit more than that if you need to. This is the number that I used for calculating the loads.
Okay.
But that transistor, this transistor is rated at like 6 amps. So that's not the limiting factor.
Wouldn't that if the fans use too many milliamps, it wouldn't limit that, just keep it at 250?
No, it won't limit it.
Okay.
There's no limiting in it, but we have a pretty beefy 5 volt supply. So that's what I'm saying. I think you could probably draw more than 250. But if you start drawing too much current, I mean, theoretically, the 5 volt supply will just fold back and then the radio will stop working.
Yeah.
But you're going to have to be pulling a whole lot of current for that to happen, and you don't want to do that.
Okay.
But I'm going to guess if you want to exceed that, I mean, if you wanted to buy an 80 millimeter fan, you could exceed that.
Yeah.
You want to buy a big fan, but the little fans won't.
I guess the fans are probably. Do you guys already have a fan in mind that you want to use?
Nope. We haven't really thought of
Okay.
that. That would be in the, when we got to the case, which is where we're getting right now. So
Okay.
that's why I'm thinking, we'll design the fans and the case together. And like I said, I don't see the need for a whole lot of airflow, but I haven't done any analysis. So.
Okay. I can't remember, but I want to say that that Fusion, why is it not letting me change? Fusion 360 does allow me to do airflow animations, or why can't I think of calculations? I can't think
simulations maybe, or
simulations. There we go. I'm not sure why I was brain farting so hard.
So you could start out with a 110 millimeter square box, 50 millimeters tall, and dump 10 watts into it, split it up into maybe 4 2.5 watt pieces spread over the boards, and simulate that and see how much airflow we need. And that'd be a great starting place.
I've never done the simulations personally on here, but I want to say that I'm a pretty quick learner, and
so
I
this
think
might be a good fun thing to do then, to figure out how that works.
I haven't done that yet, but I think I could get that done pretty quick.
Because that would be really valuable because that'd give us kind of a baseline, because we know it's about 10 watts. We know it's spread reasonably over the area of the board, and we know the approximate dimensions of the box. So we could get a really good, because if you put 10 watts into it and it says you need 200 CFM, then we know we're in trouble. But if
Yeah.
it's 10 CFM, then we can say, okay, well, we can do that. And then maybe we arrange for 15 or 20 CFM and just to get a little extra headroom. Because you know how it works. Cooler it runs, the better.
Yes.
So I mean, a lot of times the way we'll end up doing the design is you'll say, okay, this is how big the box is. These are the fans that I can get that are a reasonable price that will fit within my current budget. Plop them in there and see how, and then run the simulation with given airflow and see how much power you can dissipate. Come at it from the other way and say, okay, I can reasonably get, say, 20 CFM. What will that do for me? Is that going to be possible to dissipate 10 watts or not? Are we even close? Or is it
Yeah.
is it plenty? You know, and then because I'm all for making the flow as high as we reasonably can. So I mean, if I have to pick fans, pick the biggest ones that will fit, get the most airflow that we can get for a reasonable price. Because I think all of them are going to be so low, they're not going to be noisy. Because that's one of the objection I have is I don't like noisy boxes. But these
Yep.
fans, I don't think you can make a 20 millimeter fan that creates enough noise to annoy anyone. It's just too small.
Have you been around a server recently?
But they don't use 20 millimeter fans. They use 100 millimeter fans.
No, not the servers, not the one-use servers. They're about 10 millimeter fans and they sound like jet engines.
Oh, well, don't use those.
Either that or my cousin's PC at his shop. Man, there was a small little 30 mil fan on that thing, and that thing was making so much damn noise. That
Really, a
was
little
so
fan
annoying.
like that?
Well,
They
the
run
bearings
high
were
RPM.
going.
Okay.
The bearings were going out, and
okay.
we got a new one, replaced it. And that thing was quiet.
Yeah.
But there were also bigger fans around that you.
I like the
could
100 millimeter
hear.
fans that you can't even hear rotate. You know, they have special serrated blades and all that to keep the wind noise down.
It's crazy because they're on YouTube. There's people that are 3D print. It's this huge challenge that people are 3D printing, creating and 3D printing fans, specially
Really,
made
blades?
fans.
They're printing blades?
Yeah, and they're the three things that they're trying to do is quietness, CFM, and then I forget the third one, but those are the three things that they rate those fans on.
Probably power.
And, I can't remember, but it's kind of crazy because some of these people, they are either making some wacky blades that just happen to do something amazing, and then there's some that are like, holy crud, that thing works crazy. There was one fan in particular that was quiet and it got some pretty good CFM.
I could tell you this story about I'm a Volkswagen aficionado from the old days, right? And I remember reading in the history book, and they were talking about after World War II, when Germany produced VW bugs for the war effort. Well, when the war ended, the VW factory ended up in the British zone of occupation, and the British and the people who ran the factory, the Germans, hid all of the stampings and machines and molds in the caves nearby so they wouldn't get blown up in the bombings. Okay, so now it's after World War II, and oddly enough, the British said, we don't want the Volkswagen. The Germans, you can keep it, you can have it, which is kind of an interesting way they got started. But it turns out that after the war, there was a shortage of steel, and they were trying to change the shape of the body to use less steel. But they said they had done such a good job in the wind tunnels characterizing the shape of the body, and they only had a 25 horsepower engine. They said anything that they did to reduce the amount of steel increased the drag so much that the 25 horsepower engine would not push the car fast enough. So I mean, that's how close to the vest it was. Is like they had to be able to cruise at 50 kilometers per hour all day. That was their design criteria. And they said if they changed the shape of the body, the drag was too high and the 25 horsepower wasn't enough. So they ended up having to leave the body shape the same.
That's crazy.
It was just insane that they had engineered it so well. Any change you make changes the drag, and then it doesn't have enough power.
That's
So-
nuts. I'm sorry. I got us off onto a tangent. Sorry about that.
That's okay. We're easily distracted. So let me take this away so we can go back to.
Yeah, I
All
just
right.
posted a fan in the chat on DigiKey. It's
20,000 RPM.
20,000 RPM, 66 dBA.
What
Holy
size is
crud.
it?
40 by 40.
Yeah, that's a big one. I'm talking about a 20 by 20.
Well, I'm sure you could find one that it's equivalent. That was just a quick search.
20,000 RPM for
20,000. They got to move air through a one-use
Yeah.
server,
Well,
and they
66
don't have a lot of space.
60 dBA is pretty loud too.
Yes,
It
they
is.
are.
It is pretty loud. Okay,
That's
I'm sure there's some
like
that
a
are
model airplane
quieter.
engine.
I'm sure there's some that are quieter and don't spin as fast because
Well, do they give a rating on it? I'm looking.
So is that the same loudness as my 049 aircraft engine?
Probably. Yeah, that's what I was
Let's-
thinking.
But it pushes 30 CFM.
Okay.
That's all?
Well, it's
Well, that's a lot for a little guy.
Well, I guess so. Yeah. Okay.
less than 2 inches.
A standard 4-inch fan is 100 at CFM.
Yeah, but less than 2 inches. You're right. That's a 40. Okay.
Believe me, these servers, and we got them at work. We're working on them. They got like banks of like 4 to 8 of these things stretched across the mid plane of the server to move air across the processor. And when the processor gets hot, they ramp up, and it literally sounds like a jet's taking off.
hey, real quick, you were looking for a 20 by 20. Is that what you were saying?
The fan?
Yeah.
Yeah, I believe so. I'm looking for the part number now.
I don't see a 20 by 20. All they have is 26 by 20 at DigiKey. Oh, wait. Oh my gosh. Here it is. I found 20 by 20. There we go.
That's pretty tiny.
It's microscopic. Like I said, it moves. I think it's 3 CFM, so it's very.
It should be quiet.
It's totally silent. And you can stick your finger in it; it doesn't even hurt.
You sure you don't want a magnetohydrodynamic drive?
Jeez. Now, what I want and what I'll settle for is a lot different. So
We'll just call this Tangerine October.
Actually, that reminds me, there was a question earlier about how did the Pi connect in, and we said it was network, and it is. But I recall a discussion a long time ago about possible sidecar mounting, like a separate housing for the Pi that would connect to the Tangerine box.
okay, but it's connected with Ethernet cable, so you're not
Right.
going to really stick them together. You're going to maybe stick one on top of the other and then run a 3-inch cable in between them.
Right, but I mean, would it be nice to have something that you could screw together as an option? As an option,
Yeah.
something to think about.
Okay, I guess I was a little optimistic in the CFM rating. It was more like 1.5 CFM.
I can see what they have on DigiKey, but do you know? I can never seem to remember the equation, but how do you get watts from volts and amps?
Multiply them together.
Multiply. Okay.
Okay, here I've got It's a Sunon, sorry.
So we got a lot of watts.
Let's see if DigiKey actually still carries these anymore.
So how much?
I'll give you the DigiKey part number. They're only using the IQ2.
So we got. Does this sound right? 1,250 watts.
No. Remember, it's so 5 volts at 250 milliamps is about 1.25 watts. It's milliamps.
That's what I'm doing wrong. Milliamps. Dang
Quarter
it.
of an amp.
Never mind. Okay, so you said 140 milliwatts.
1,250 milliwatts.
1.2 amps.
It's a quarter amp by 5 volts. So 1/4 times 5 will be 5/4 or 1 1/4.
So
Which can get very hot in a closed space.
Yep. And so that's why this fan that I'm looking at is consumes 0.45 watts.
so that's 1.25 watts.
No,
For the fan?
0.45 watts. It's 5 volts at 90 milliamps. And it is 12,000 RPM,
Jeez.
but the blade's only, it's incredibly small. Actually,
So-
that's not the one we're using. That's the smaller one. This is 155 milliamps, and it runs at 14,000 RPM. So I'm trying to get you the data sheet here on the fan.
The Sunon,
Yeah,
I just found oh God, it's tiny.
it's tiny.
Well, no, this one's like 9 by 9.
No, this is 20 by 20 is the one I believe we use.
So you're talking about this Sunon, it has 23 decibels.
That's quiet.
1,500
think this
RPM,
is-
15,000.
Okay. Hold on a second here. Where did my controls go? Am I still sharing my screen? I'm not.
No.